So, good morning, class. BA505 homework number 2. I wanted to walk through these problems with you so that you can see exactly how to work these problems, and we'll be flipping back and forth between this screen and then the calculator screen. So, just so you're aware, that's why I'm going to be working these problems so that you can understand how to use the calculator if you wanted to. You're certainly welcome to use the formulas. As I have told you before, the formulas are much more complicated, and I will accept either, but as long as you show me your work with the calculator, then you'll get partial credit too that way as well. So whatever is easier for you. Again, I'm going to be working with the Hewlett-Packard 12C, and I hope that this will give you some understanding. So problem number 1 for the homework. We have some specifics here, and in regards to Chocolate and Moray offers a bond with a coupon rate that of 6%. And notice these are semi-annual payments. And so whenever we are actually working the problem, semi is 2 times. So, we just want to make a note that semi payments are there. Again, if you're working with a calculator, we are going to be filling in the blank with our variables. So N, an I, PV, PMT, and future value, okay? So it doesn't have to be that complicated. To me, the calculator does the work for you. And so let's walk through this just so you can understand. So because we have a coupon rate of 6%, a coupon rate means that that's the amount of actual monies that are paid by the bond every 6 months in this case. So 6% with a face value of $1,000 means that this bond is going to pay you $60 per year, or $30 per payment period. So if we are understanding that, then we can move forward with other items here. Because we have semi-annual payments and we're looking for the bond maturity in 9 years, okay, we're looking for how many interest payments. So if there are 2 a year, then we have 9 times 2, or 18 interest payments, okay? And so we're looking for the market price. So the market price is always today's price. What are we looking at? That's what we're solving for, is the present value. Our future value is $1,000. And our interest rate, these bonds are priced to yield to maturity of 7.73%, okay? So again, because it's semi-annual, we're going to divide this by 2, okay? Because that 7.73 is not the periodic yield to maturity until we divide it by 2, okay? So solving for a present value, we actually have solve for, we have 18 in for N, 18 in for N, let's clear our calculator, okay? So we have 18 for N, we have 7.73, enter 2 divided by. For I, we're solving for present value. Our coupon payment is $30 every 6 months. Our actual future value or maturity value is $1,000, and we just simply want to solve for the present value. So $889.29 is what I get. So I'm going to go back to my presentation, and present value is equal to 889.29. Okay. So let me change my marker just a bit and make it just a little bit bigger. Okay. All right. So if you have any questions about how to work that problem, feel free to just send me an email or whatever. When we move to the next problem, we're going to have a similar problem, but a little bit has changed, but not much. So let's work through this problem too, okay? So Guggenheim offers a bond with annual payments and a coupon rate of 5%. So we're not having semi-payments, we have annual payments, okay? So the coupon rate is 5%. So again, I always get in the habit of writing down my actual variables that I'm looking for, and let's just see if we can go through this as well. So and let's just move that up a bit. So in case I need a little more space, I'll have it. So N, and then I, and then PV, and then PMT. If you notice, I put these in the order in which they show up on the calculator. And it's easy for you to follow if you do the same thing in your homework or in your test. If you are working a multiple choice test and you put these variables down in this capacity, you won't be as likely to get the problems wrong as long as you put the numbers in the right places. You know that. So in this problem, we still have a face value of $1,000, okay, or maturity value. We are actually looking for annual payments and a coupon rate of 5%. So 1,000, our payment is going to be $50. Again, that's just 1,000 times 0.05%. Okay, we're still solving for the market price, so that's still today's price or the present value. The yield maturity is 5.62%, so 5.62, and the maturity date is, again, 9 years. Okay, so we're going through this process just to show you the difference in, a couple of things there, but pricing specifically. So if we're going to solve for our present value again, which is today's price, we have 9 for N. We have 9 for N. Again, I'm going to clear my calculator. So we have 9 for N. Okay. What was the 5.62 for I? So 5.62 for I. We have 50 for our coupon payment. Our future value or maturity value is $1,000, and we're simply going to solve for the present value, $957.12. Okay, so $957.12 is our price. Okay, let's move forward on to number 3. Okay, we're still talking about bonds in this problem, so let's just continue to go forward. Let me change, let's just do a different color just for variety. Brighten up things for you. Okay, so exactly 3 years ago, so here we are on a timeline. Okay, and exactly 3 years ago you purchased a $1,000 face value. So 3 years ago, so today, this is today, and so we have 1 3 years ago, okay, we invested $1,000, okay, in a bond. I'm sorry, we bought $1,000 bond, but we only paid 12, 11, 16 for it. So 12, 11, 16 is what we paid for it, okay? The maturity again is $1,000, okay? The coupon rate was 6.5% with interest paid semi, okay, so semi. And our coupon rate is 6.5%, so at $65 per year. And since it's semi, it's 65 divided by 2, which is going to be equal to $32.50 per every 6 months, okay? So again, if we're in IPV, PMT, and FV, okay, we actually have our $32.50. Okay, the coupon rate was 6.5% with interest paid semi-annually. Today, you sold that bond for $1,089.54. Okay, today you sold the bond for $1,089.54. What was your rate of return for the 3-year period or holding period yield on this investment? Okay, so we're going to be calculating this problem just a tad differently, just simply because we won't be using the actual time value of money problems or variables for this problem. So let's just erase this, okay, so that we can use this space for something else that would make more sense for us to use. So again, so we're asked to solve for what is your rate of return for the 3-year period. So it's basically from here to here, okay, or the holding period yield. So the return or the yield on this investment, okay. So the holding period return, okay, is just simply the actual dollars return if our beginning or purchase price, let me back up just a second, okay. Let's move over. So our selling price minus our purchase price, okay, divided by our purchase price, okay, plus our coupon payments, plus the coupon payments during that time period, okay, is going to give us what we're actually looking for. So whenever we actually are looking for that scenario, it looks like we sold it for $1,089.54, okay? So in this case, our selling price of $1,089.54, okay, minus our purchase price of $12.11.16, okay, plus our coupon payments, and we have basically semi-annual, so we have 3 years of coupon payments. So 65 divided by 2 is equal to $32.50 times 6, if you will, okay? And that's going to give you 195. Okay, so plus 195, all of this divided by our purchase price of 1211.16, and that in itself is going to equal to a return of roughly 1089.54. Let's just do this with the calculator. So F clear, 1089.54. I'm going to enter that, okay, and then 1089.54 minus 1211.16 minus 1211.16 minus, and then we actually can go ahead and add into that our coupon payments, 195 plus. So all of that is in our system. So 73.78, enter, divided by 1211.16. It's 6.058 is what I get as the actual answer. So 6.06% is our actual return. Okay? If you see how that works. Let's move on to the next problem, okay? And we'll see how this actually works too. So I want to be able to give you somewhat of an idea here that we're moving into the discussion about stocks and average rates of return and so forth. We're actually trying to see, in this case, a couple of things. So let's just get started and we'll walk through this. MJ Enterprises stock traditionally provides an average rate of return of 11.6%. The firm's next annual dividend, okay, again, remember next is awfully important, okay? Next is the dividend that we're looking for with our actual formula, okay? So the next dividend is projected to be $2.40. So that's going to be dividend 1 is going to equal to $2.40, okay? With future increases of 3% per year. So G, our growth rate, is equal to 3% per year, okay? Provides an average rate of return of 11.6%. This firm's next annual dividend is projected at $2.40. With future increases, what price should you pay? Okay, so we're still looking for, if we're satisfied with the firm's average rate of return, again, so in that case, our R, our required return, is going to be equal to the average rate of return of 11.6%, okay? So using our dividend discount model, we're trying to solve for a piece of 0 or today's price. And in that case, we're going to be looking at 2.4 as our dividend, okay? And it's just going to continue to grow at the constant rate of 3%. And in that case, let me just write the full formula down for you again. So in that case, our formula is D sub 1 divided by our required return, R minus G, okay? And in that case, D sub 1, again, we know is 240. And when we divide that by R in this case is a percent, and we enter it in the formula as a decimal. So it's going to be 0.116 minus 0.03, okay, for our growth rate. And that is actually going to solve for, 240 over 0.086, which is equal to, and we do the math, a price for P naught, which is equal to 27.91. Okay? All right. Let me work through number 5, and then I'll probably take a break and post homework number 2, session 2, and we'll pick up with that next problem. But we'll work through this one first, just so you can see how it's going to play out, okay? But in this case, how much are you willing to pay for 1 share of stock if the company just paid an annual dividend of $1.03? So their last dividend, they just paid an annual dividend, okay? They just paid $1.03, okay, as their dividend. And in this case, the dividends increase at the rate of G is equal to 3% again, okay? Dividends increase by 3% annually, and you require a rate of return of 15%. So R is equal to 15%. Okay, so similarly, we're going to work this same problem because, we don't know what the next dividend is. And so if this is D sub 0, okay, we have to calculate what is D sub 1, okay? What is this dividend, the next dividend, okay? For us to be able to calculate the price at P sub 0, what is that? Okay, that's what we're solving for. So D sub 1 is just going to be 1.03 times, which is our former dividend, times, again, 1.03. Okay, so that's a 1. Okay? And in that case, that dividend is equal to 1.0609. Okay? And our formula now is, we can put this to use. So D sub, or P sub 0 is equal to D sub 1 divided by R minus G. And in this case, that is equal to 1.0609 divided by 0.15 minus 0.03. And in that case, that reduces down to $8.84. So P sub 0 is equal to that. Okay? I'll pick up with problem number 6 on the next session. Thanks.